control a real-time snake game using a joystick, and not just on your phone, but on an OLED screen powered by two ESP32s. Every tilt of the joystick moved the snake in real time over Wi-Fi. Now special thanks to our awesome subscriber Electrospark Wi-Fi by Shivraj D1H8I and I Jaknikabau 2625 for requesting this project in the comments. These ones are dedicated to you. If you have a wild idea, drop it in the comments. It might be our next big build. For this project, you need two ESP32 Dev Boards, one joystick module, one OLED display, jumper wires, two micro USB cable. Now step 1. Wiring the transmitter joystick ESP32. Let's start by wiring the first ESP32, which will act as the controller. Take the joystick module and connect it like this. GND to GND, VCC to 3.3 volt of ESP32, VRX x-axis to GPIO 34, VRY y-axis to GPIO 35, SW that is button press to GPIO 32. These ESP32 reads your joystick inputs and send directional command like up, down, left, right over UDP Wi-Fi to the other ESP32. Step 2. Wiring the receiver ESP32 with OLED. GND to GND, VDD or VCC to 3.3 volt, SCK to GPIO 22, SDA to GPIO 21. This ESP32 receives the joystick directions via Wi-Fi and moves the snake accordingly on the OLED display. Double check the wiring according to the circuit diagram before proceeding. Now download two code files given in the description below. Let's begin with the code for the transmitter ESP32, the one connected to the joystick. Open the code file if you have already downloaded the Arduino IDE, otherwise download the Arduino IDE first. Now step 1. Include required libraries. Wi-Fi.h helps us connect ESP32 to a Wi-Fi network. Wi-Fi UDP.h allows us to send data over Wi-Fi using the UDP protocol. Lightweight and fast. Step 2. Define Wi-Fi credentials and receiver IP. Replace your _SSID and your _password with your actual Wi-Fi credentials. Replace 192.168.x.x with the IP address of your receiver ESP32, which will be displayed on its OLED screen at startup during boot. UDP port is the port both devices use to send and receive packets. Both transmitter and receiver must use the same port. Step 3. Create UDP object. This initializes a UDP communication object. Step 4. Define joystick pins. X pin and Y pin are connected to the joystick's analog outputs. SW pin is for joystick's button, but we are not using it in this logic yet. Step 5. Set a function. Start serial communication for debugging. Connects the ESP32 to Wi-Fi and waits until it's connected. Sets the button pin as input with pull-up, even though it is unused in the main logic. Step 6. Main loop. Reads analog values from the X and Y axis of the joystick. Analog read function gives a value from 0 to 4095 for a 12-bit ADC on ESP32. SW reads the joystick button, not used now but can be extended. Step 7. Determine direction. Based on the joystick position, we set the movement direction. Center values are around 2000 to 2500, so use threshold to detect directional tilts. Step 8. Send UDP packet. Sends a direction string to the receiver only if the direction has changed since last time. Prevents flooding the receiver with repeated data. UDP begin packet function start the message. UDP.print direction writes the direction and UDP end packets function sends it. Step 9. Small delay. Adds a 100 millisecond delay to control the sending frequency and avoid rapid updates. That completes the transmitter code. The joystick now sends real-time directional commands over Wi-Fi to the second ESP32. Now plug your ESP32 into your computer using the USB cable. Here select board ESP32 Dev Module, then port and check which COM port your USB is on. Now click the upload button. If it shows connecting and dots and keeps looping, press hold the boot button until it starts uploading. Now let's move to the receiver ESP32, which receives the direction updates and display the snake game on an OLED screen. Open the receiver code file. Step 1. Include libraries. Wi-Fi and Wi-Fi UDP handle network communication. Adafruit_GFX and Adafruit_SSD1306 are used to draw on the OLED display. Step 2. Define Wi-Fi and UDP variables. Same as before, set Wi-Fi credentials and UDP port. Incoming is the character array to store the received direction. Step 3. OLED setup. Initialize the OLED screen with 128 by 64 resolution using I2C communication. Step 4. Snake game variables. Point structure stores X and Y positions. Snake holds the position of all segments. Length is the current length of the snake. Food stores the food block's position. Direction is initially right. Step 5. Food generation function. Randomly place the food on the grid in multiples of 10 pixels. Step 6. Draw the game. Clears the display and draws each snake segment and food as 8 by 8 blocks. Step 7. Move the snake. Shifts snake position, updates head direction based on input, checks if food is eaten and grows the snake, checks the boundary collision and reset the game. Step 8. Setup function. Begin serial communication and initialize the OLED. Connects to Wi-Fi and shows the progress on OLED. Displays the IP address. Note this is needed on the transmitter side. Initialize UDP snake position and generates the first food. Step 9. Loop function. Checks if any UDP packet has been received. If yes, reads it and updates the direction. Then moves and draws the game every 200 milliseconds. And that's it. You now fully understand how the ESP32 joystick sends movement data to another ESP32 that runs a snake game on an OLED display. Now plug your ESP32 into your computer using the USB cable. Select board ESP32 Dev Module. Then port and check the which COM port your ESP is on. Now click the upload button. If it shows connecting ... and keeps looping, press and hold the boot button until it starts uploading. That's it. Both ESP32 boards are now programmed and ready to communicate over Wi-Fi. Now let's test it out. Tilt the joystick in any direction and see the snake follows your command instantly on the OLED. And yes, the snake eats the food and grows and crashes into the walls. If resets, just like the retro game we all grew up with. If you enjoyed this project, hit like, share and subscribe for more such cool DIY tech tutorials with RoboArmy.